This presentation is on fluid heat, energy, environment nexus, and sustainability. The topic has been divided into three arms of phenomena: the fluid environment, the fluid heat, energy, environment nexus, and sustainability for non-renewable sustainable energy, and the fluid heat, energy, environment nexus, and sustainability for renewable and sustainable energy. As mentioned, figure 1 in the next slide shows the process flow, and the sustainable drivers will also they are also itemized in the figure. The figure shows the overview of the topic, and each component will be discussed in detail in the subsequent slide. The three parts that constitute this project are fluid environment, fluid heat energy environment, which is the non-renewable sustainable energy, and the fluid heat energy environment, which is the renewable sustainable energy. For this phenomenon, which is the fluid environment, the major driver here is the Nexus number, and we will use the gas flow in nanopods to explain. This figure shows the velocity profile that transpire in the gas flow in nanopore, and this is is guided by the convection and diffusion phenomenon. Figure 2 are the regimes, and also the Nexus numbers in the various regimes. This slide confirms for fluid and environment nexus that Nexus number drives sustained gas mass production with respect to the responsive properties like Nexus diffusion, pressure, and permeability ratio. For the second phenomenon, which is the non-renewable sustainable energy, we will use enhanced oil recovery techniques, and they are itemized there. So the driving parameter is the heat transfer, and we will also look at the responsive properties as mentioned in the slide. Thank you. In this example, which is the steam simulation, the bottom line is that heat transfer in steam simulation drive sustainable oil transfer, oil mass production, and the adjacent figure shows all the profile, and the equation 3 is the governing equation. For this example, which is the superheated steam transfer profile, we can see that it has the same profile as steam simulation, but differ in temperature and steam quality, and the figures are the adjacent figure to explain why the equation 3 and 4 are the governing equation. For this example, which is horizontal well fracturing, the bottom line here is that the hydraulic fracture, which is the injection rate, drives the fluid flow and also sustain the mass production of oil with respect to the responsive properties like leak off, fluid leak off, and the volume change. This is the last example on non-renewable sustainable energy, which is the light emitted diode heat transfer. And the bottom line here is that active cooling is better and preferred due to high distribution ability, and heat transfer drives reliability, longevity, and good performance of LED. For the top phenomenon, which is the renewable sustainable energy, biofuel production will be used to explain the media. And the driving parameters, is the enzyme kinetics, which is with associated responsive properties like temperature and measuring speed. So the figure 11 shows fossil fuel versus biofuel refinery, and which is governed by the same process and product, but different raw material. This figure shows the biorefinery process diagrams and the three ways that can lead to bioethanol production. The first major way is the pretreatment to get the raw materials for enzyme or acid hydrolysis, the aromatics and the hemicellulose. So that leads to fermentation and to bioethanol. The second process, which can use all the bioproducts, is gasification. The third one is pyrolysis. So this is cradle to grave process. Here we briefly explain the significance of enzyme substrate kinetics, and which is governed by mechanism maintained, which drives sustainable biofuel production. And I think equation 6 and 7 shows the mechanism maintained equation. One where we have the first one is constant substrate concentration, the one with constant substitution, and the other is equation 7 is constant enzyme concentration. There are two ways of two ways of reaction that entails biofuel production. Both equations are they are a steady state condition, and the Adediran figures shows the raw material as from the cradle from plant cell to how every cellulose and cellulose are being generated or being recovered from plant cell. And the figure 14 shows the process flow diagram for, just like what we have been explaining before, the various process to get the bioethanol or biofuel products. On this slide, we'll just briefly mention the 3 steps that constitute biofuel production, which are lignocellulose pretreatment, enzymatic hydrolysis, where enzyme kinetics is dominant and by the mechanism maintained. And of course, the last process is the fermentation. And the adjacent figure shows the enzymatic conversion of lignocellulose and the fermentation process, which from glucose to byproduct to product, final products of ethanol and butanol. For conclusion and recommendation, so for first phenomenon, fluid environment, we need to find the effect of hydraulic fracturing on nanopore and Nexus number. We could note that nanopore decreases Kn, and once Kn decreases, it affects the shale gas production. So we want to know how we can make nanopore responsive rather than mere reactive. For second phenomenon, which is the non-renewable sustainable energy, we have looked at 4 various examples to describe this phenomenon. The other examples are steam flooding, hot water flooding, in situ combustion, steam-assisted gravity drainage. So we need to further explore these examples to know the importance of heat transfer in their various mechanisms. And of course, we can also itemize them in terms of reliability and ensuring sustainable oil production. And for third phenomenon, which is the renewable and sustainable energy, is there a way we can do away with enzyme and produce biofuel without enzyme, or any alternative that we can use, or how can we improve on the enzyme substrate kinetics? So those are the observations and the recommendation here. So, and the subsequent slides here are just the references which we have used to develop this project. And on this aspect, we conclude this presentation. Thank you.